Assalamualaikum. My name is Muhammad Nur Iskandar bin SUFIAN, together with my partner, Dyrand Yesiling Katuayan and mentor Dr. Marlena binti Yakno. We will be presenting our entry to the UMPSA Altair AI Studio Challenge with the title of AI-powered phishing website detector. So, what is phishing? Phishing refers to an attempt to steal sensitive information, typically in the form of username, password, credit card information, or bank account information in order to utilize or sell the stolen information. By masquerading as a reputable source with an enticing request, an attacker lures in the victim in order to trick them, similar to how a fisherman uses bait to catch a fish. University environments like UMPSA have become prime targets for cybercriminal due to the high volume of sensitive personal, financial, and research data flowing through campus network. Students are vulnerable to targeted phishing scams disguised as urgent notice about tuition fees, scholarship, or exam result suspension, which often designed to trigger panic and steal student portal credential. Similarly, lecturers and researchers face sophisticated attacks where scammers impersonate university administration to steal research data or divert research funds. The challenge at UMPSA is that generic commercial spam filters often miss this hyper-localized attack, such as a fake email that look exactly like the UMPSA staff. Relying on student or busy staff to verify every official-looking email is risky, as a single compromised account can grant attackers access to the entire university intranet. Therefore, there is a critical need for a customized and automated detection system that understands the specific pattern of academic phishing attempts to protect the campus community effectively.
So this is the dataset for our project. So as you can see here, there is a lot of column here. So this is the actual dataset and real dataset. We did not use dataset that we make by ourselves, but we use the real dataset that we downloaded from Kaggle website. So as we can see here, we got index, using IP, long URL, short URL, and many more. So the total data inside this dataset is 11,055 website inside this dataset, which is it's already good enough to use to train the AI system, especially for our project. So this is the design for our system. So firstly, we got retrieve here, which is we will use to load our dataset, because without this, we cannot load our dataset, which is this that I shown you before. So next, we got numerical to polynomial, because as we can see here, the dataset actually only use number to classify every column here. So if we didn't use this, the system or this module will not know how to classify it, because it's in number, not in words. So we use this to convert the numerical to polynomial, which is in words. So by doing that, our system or this design, this project can classify what did we want inside our system. So as we can see here, we use class attribute as class that we want to convert, because here we can see negative 1, 1, negative 1, 1. So actually negative 1 is for phishing website, while 1 is for safe website. Then we got set role. So basically, this is just to set or target which column that we want to classify in this data set. So in by for our case, we want to target the class, because we want to classify if the website is phishing or safe. Okay, as we can see here, the attribute name is class, and then target role for this attribute is to label it. Then we got split data. So basically, this is just split the data. Okay, so as we can see here, the ratio is 0.7 and 0.3. So 0.7 is mean we separate it 70% for training data, while 0.3, which is 30% for testing the data. So why we do that? Because if we not split the data, the module will only memorize the data instead of learning the pattern. So by do if we doing that, our system can be overfitting, because it's just memorize the data. So next we got decision tree. So basically this is for the 70% that we used before to training the data set. So basically in decision tree, it will make a flowchart, which is the if else condition. For example, if that condition happen, what is going to happen? Else, what is going to happen? So that was the example for decision tree, which is if else condition. Then we got apply model, which is for the testing data that I show you before, which is the 30% of testing data. So here it will take a guess about if the website is phishing or safe. So next we got performance. So basically this is just to show the percentage of accuracy and also the classification error as we can see here. So if I run the module, okay, as we can see here now, the accuracy for our design is 94.39%, which is already good enough because our target is more than 90%, and we got more than 94%. So as we can see here, so basically negative one is for phishing and then one for safe website. So prediction for phishing, the class precision is 91.52%, while the prediction for safe website is more than 96%, which is quite high. Okay, next we move to classification error. So we only got 5.61% error, classification error. So as we can see here for phishing website, the class precision is 91.52%, while for the safe website, the class precision is more than 96%, almost 97%, which is already good for this model.
The implementation of this AI-driven system offers a security solution tailored for the UMPSA environment. First, it can be deployed as a lightweight browser extension on all UMPSA library computers and made available to students and staff. This provides an immediate, low-resource safety net for them, ensuring that everyone with the extension is protected from phishing attempts in real time without slowing down the machine. Second, the system can be integrated with the university Wi-Fi so that it can be embedded directly into the campus firewall. This allows for the automatic blocking of malicious domains across the entire network, preventing threats from ever reaching students or staff devices connected to the university Wi-Fi. Finally, the project directly enhances student safety by recognizing the patterns of scholarship scams and tuition fee fraud, which will help in preventing students from falling victims to predatory attacks that disguise themselves as official university correspondents. In conclusion, this project demonstrates how Altair AI Studio may be used to create a customized security solution made to meet the particular need of phishing detection. We have moved beyond generic protection to create a system that addresses the unique vulnerability of the university community. By using this system that requires no coding knowledge to operate, we ensure that students can focus on their studies and researchers on their innovation without the constant fear of falling victim to digital fraud. That's all from us. Thank you.